Yeah. The next concept is bit masking. Okay. So, did any one of you hear about this word?
Yeah.
Okay. And what it actually does?
I mean, it's just used for like manipulating things.
Okay. So, in general, bit masking is about representing some information in bunch of zeros and bunch of ones. Okay.
Okay.
Let's talk about a very famous thing, which is, let's say you are given some numbers 2, 4, 5. Okay. How many of you can find all the subsets of this? So, what are the subsets? Subsets are what?
2, 4, 5, 2, 4, 4, 5, 2, 4, 5. Yeah.
Right? So,
Mm.
given a array of length, then how many subsets are possible? Sam?
2 power n.
Nice. Sas, how many subarrays?
2 power n
Subarrays.
subarrays.
2 power n -1.
How many?
2 power n -1 na?
I
No,
said subarrays.
Yeah, n into n plus 1 by 2.
Yeah.
N into n plus 1 by 2. Manan, do you agree? Or it is wrong?
3, 6.
I did explain this concept, right? If you have to find a
Yeah.
subarray and
Yes,
you have a windows available, take
n
any two
n plus 1 c.
plus
n
n
plus
plus 2.
1 C2. Yeah.
Mm.
Yes, bro, what happened? I told right on that day.
Yes, yes, bro.
Yes,
Then
yes.
you have n plus 1 boundary lines. You can choose any two. N plus 1 choose two. This is nothing but this only, right? You have to remember, guys. It does not work like this. Okay. Yeah. So one thing is, given some set of numbers, you have to print all the subsets of a number. Okay. So can anyone do this using some kind of approach?
Like recursion will be like using.
Okay. Yeah, recursion works. Others, do you know? I mean, at least do you guys know how to code on recursion? This one?
Yeah, yeah.
Oh, okay, fine. So I'm not taking about recursion. Okay, I guess we are starting from tomorrow or maybe next after that. But since we are talking about bit masking, so bit masking is about representing some information, right? So what the numbers we have is 2 comma 4 comma 5, right? How many subsets we have?
2 power n
Which is nothing but
Super.
8.
8.
8.
Okay,
Yeah.
I'll write something. You guys observe it, okay? And tell me what will be my next subsequent numbers after a certain point. Yeah. Can anyone tell the next number?
1 double
100.
101
101.
110.
11.
110 triple 1.
Yeah.
And what is this? 0 to 8, right? 0 to 7, in fact. These
Yes,
are
yes.
8
Yeah.
numbers, correct?
Yeah.
Yes.
If each of the bits are 0, okay, represent this like this. Think it as like this. Okay. Hey, what, Dev? I asked you to sleep afternoon, right? Why you are
What?
नींद आ रहा तेरे को? चलो ठीक है.
I just go.
0 0 0, right? So that means each of the number is not present, which is nothing but an empty set.
Yeah.
Next, you see, is the bit set?
Yeah.
That means it's 5.
Okay.
Is the bit set?
Yeah. So
Yes.
it's 4. 4 comma 5. 2, 2524.
Are you guys understanding what I'm writing?
245.
Others?
Yes.
So what I did is, wherever a bit is set, I just took that number. And wherever it is not set, I'm not taking that number. Right? In fact, this is a very cool
Hmm.
way to represent some information, right? So given a set, you have something which you want to check whether a number is being taken or not. You can just go for a particular bit and check whether it is one or not. If it is one, I will take that. If it is not, I will not take it. So can you see, using bit mask, you have represented all the subsets.
Yeah.
So probably at this point you guys might not aware of the power of this, but this is a very cool trick which is used in many problems. Okay, where you have some bunch of information available and you have to take some subsets of it. Okay, so what you do is you can use this bit masking idea where you can take some information out of it and represent each of the numbers, right?
Okay, got it.
Yeah, so shall we code this?
Yes, bro.
Yeah,
We shall, right?
Yeah.
Yeah.
yeah,
Ask Manan, what do you guys think? We should?
Yes, bro. Yeah.
Yes, yes, yes.
Okay.
Sure.
Show more options. So then we code. Okay. Okay. So what do we have? Bitmask dot. Now this concept again we will iterate on DP. So there is one concept in DP also, which is bitmasking DP or DP on bitmask, where again we will see this concept and see how few problems of DP can be solved using this technique also. Cool.
okay.
So what we have, I don't know why this is not coming. Class bitmask PSVN, right? We do some initial setup. Okay, we'll create our scanner class, little quick, and we will take number of, okay, I'm just taking those numbers 2 3 5 in our array, right? Then okay, so
Yes.
what we have
Yeah,
done is we have taken all the numbers. Okay, now why this is, yeah. Now the next thing is we have to print all the subsets which are present in this array, right? So how many subsets will be there?
yeah.
2 power n.
2 n into n plus 1 by 2 subsets.
I just now explained you guys, right?
2 power n.
Subsets to power of n, subarrays n
Subhead
into n
N
plus
and
one.
plus
12 plus
1.
1.
Yeah,
What, Deva?
yeah. Sorry,
So
रिवर्स में बोला.
yeah, tell me in the bitwise form. So we have seen this, right? We will start from 0 to 7.
2 power n minus 1.
Yeah, so 2 power n minus 1, right?
Yeah,
Yes.
So how can I write that? Can I write subsets less than 2 power n?
Yes.
So how can I represent 2 power n using bits? I mean,
left shift.
left shift of
Yes.
what?
2 comma.
Not comma. It should be something operator. Just now we saw, right? 2 power x.
Uh, okay, like x into x minus 1.
No, no. One
Tell.
left shift y.
Yeah, so something you're saying?
One left shift y n, right?
Nice, that's all. Hey guys, one left shift n is nothing but 1 into 2 power n, right?
Yeah,
What? Sampath,
2 power.
Yeah, yes, bro.
Manan, did you get this?
Yeah, yeah.
Sure or not?
Yeah.
Hey, if you are having doubt, ask me, man. It's not we are not sitting with teachers or someone. We are here to learn.
Okay, and n का मतलब it will be like increased by n, like the values, right? Like the powers, it will be jumping, right? So that's the reason, right?
N, let's say we have n equals to 3. That
Four.
means there will be 8, right? So
Yeah, yeah,
8,
exactly.
8 we have represent just now at 0 to 7, right? Somewhere 0 to
Yeah,
7. So is
yeah,
it nothing but 0 to less than 8? 0 to less than 8 means 0 to 7 only.
yeah, yeah. Got it.
समझ आया? Others?
Hmm.
Yeah,
Yeah.
got it, bro.
Current subsets. Okay, right? Now what I have to
Yeah.
do is, this is my number. Subset is nothing but this is the number. Okay, this number, this number, this number. What we have to do, we have to check whether, given this number, whether a particular bit is set or not, right? Whether
Yeah.
this
Yes.
bit is set, this bit is set or not, this bit is set. So how many total?
Three.
So I mean, if there are four elements, there will be four, right?
Yes. Yes.
Yeah.
Yeah. So I will go through. Can I write like this?
Yes.
Yes.
Now what I have to check, whether a particular bit is set or not.
Yes.
So what is the formula? Just now we saw, we need to check, given a number subsets, because we are iterating on subsets, that per current bit. Okay, I will make it as bit. It would be much easier to understand and write it. Okay. What I need to do, I need to check whether a particular bit of a subset is set or not. Who can tell me this?
Set or not, right? And percent operation. That's it, right?
No. Tell the perfect one. What I should write in order to check whether a bit is set in subsets or not. Manan, try it.
It is
This is the number. Okay.
subset and
Nice.
one left shift of bit.
Okay. Nice. What I have to check?
Yes.
Whether it will be less than 0, equals to 0, greater than 0. What should I check?
Greater
Yeah,
than
that should be equal to one.
one.
No. No. Greater than 0.
Greater than 0. No. We just saw that somehow if we have a number greater than 0, that means that bit is set or that bit is set,
Yes.
right?
Yeah.
That means, can I add my current number?
Yes.
Yeah.
Yes.
Can I write this? I'm just
Yes.
Yeah.
setting into current subsets, okay? And once done,
Okay.
I will just print them. Got it? How many of you are clear with this?
Could you just show me the 10 values and stuff?
Bro, once
एक
again,
थोड़ा.
complete.
Yeah, yeah, sure. Okay, so let's run once and let's see. Okay. So what we have is three numbers, right? 2,
Hmm.
3,
4.
4.
5.
Yeah.
Correct.
Yeah.
4, 5. Yeah.
So you can see a space, right? Space is nothing but empty, empty subset. Okay.
Yeah.
We got 2, we got 4, 2, 4, 5, 2, 5, 4, 5, 2, 4,
Yeah.
5.
We got 8. All
We got
right.
8, right? Okay. Now let's
Yeah.
again go through this. Okay. What we are doing. Subsets are, there will be 2 power n subsets, correct? So each
Yeah.
of the subset I can write it as 0, 1, 2, 3, up to so on, up to less than 2 power n, correct?
Yeah. Exactly.
Now for each number, what I have to check is whether that particular bit is set or not in that particular that subset.
Hmm.
If it is set, I will add it. That's all.
Yeah.
If it is set, I will add it. And finally, once we are done, we will just print it up so that we can see what are the numbers which we have set.
In the particular set. Okay, got it.
Sam,
Yeah, got it, bro.
sure.
Yeah, sure.
Sahas, Manan,
Yeah, understood, bro.
Hmm.
Manan, do you have anything to ask?
We are adding, matlab what we are adding?
This one,
हाँ हाँ.
this one
Um,
is nothing but
the value
the
to
value whatever is been we want to display.
considered for that
Hmm.
particular time.
Mm-hmm.
Like,
See, it's like you have taken two, right? So
हाँ.
you'll be like converting that into a bits of zeros and ones, right?
Yeah.
Then you'll be like taking like one of the left operation, like the one left bitwise of bit, right? So
Hmm.
then you perform and operation. So if the value, the resultant is greater than one,
Mana,
you'll be like
हाँ.
answering that.
you have this number, okay?
हाँ.
This is nothing but 011, right?
011. हाँ.
We are saying that this number and this number we need to take it, correct?
Yes.
So, uh, adding means taking these numbers. That's all.
ओके हाँ ठीक है. या ठीक है ठीक
Done?
है. या हाँ.
Okay. Sal, brother, what is the time complexity of this?
Hmm.
How many times we are
Like
going at the top?
eight, eight.
Are they were not in
I mean, two per n
consecutive
times.
16,
Two per n
2
times.
power n. And this one,
10 times.
n times, right? So can I
Yes.
say 2
Yeah.
power n into n?
Yes.
Yeah.
Sam, Manan, do you guys agree?
Yes. हाँ. Yes.
Right?
Yeah, yes, bro.
Okay.
Yeah.
So now if in 1 second we can write 10 power 8 statements, okay, then what will
Mm.
be the, if n is greater than or equals to 30, it won't pass, okay. So in general you do bit masking for n is across 20s, okay. So if you have n equals to less than or equals to 20, you can use this to print all the subsets, okay.
Yeah.
Okay, done, right?
Yes, bro.
Yeah.
Yes. Yes.
Okay, chalo, next concept. Hmm. Okay, so the next question is, you will be given two numbers, L comma R, okay. What you have to do is you have to find L XOR, L plus 1 XOR, L plus 2 XOR, up to so on R. That is, from L to R you have to do XOR of the number and you have to tell me what's the value. Is the question clear? Let's take 5 8. Okay, we have 5 XOR 6 XOR 7 XOR 8. The value will be something, I am not sure. Okay, but this is what you have to do.
Hmm. Fives or sixes.
No,
Okay.
leave about value, I'm just telling this is the operation you have to do, okay. So the
Yeah.
question is how to find the value. I mean, given L comma R, you have to tell quickly what will be the value. Can everyone do brute force?
Yeah.
Yes,
Others?
just
Yeah, just writing a for loop, right? L to R, that's all.
yes, yes.
Yeah. That's it.
Brute force is done,
Yes.
right?
That's it.
Performing.
The problem comes
Yeah.
when they ask you queries, that every time I will give you two numbers and q is up to 10 power 5, L and R are up to 1 comma 10 power 9. Then it's a problem, right? You
Yeah.
cannot write for loop from 1 to 10 power 9 for 10 power 5 times. Now you have to tell me how we can optimize it. Okay, fine. Yeah, I'm not taking much time because this is something we have to know before solving. Okay.
Okay.
Yeah. So what is the bitwise OR of 1?
Bit by zero of one.
Only 1, right?
One. Yeah.
2. What is the bitwise OR of 1s or 2?
1 1 0. Yeah, 1 1 3
What is the bitwise OR of 1 2 3?
4.
No.
Okay, one again.
Others, 1s or 2s or 3. What is the value?
Mm, 0.
0.
0, right? 1s or 2 is
Yeah, three
Zero.
threes or three. You'll get A's or A. Yeah, 0.
Bro, how bro? Like we need to take the previous one.
no 1s or 2s or 3. I am not telling any formula. I'm just saying asking you to write the values. That's all.
Okay, okay.
Values.
Okay. 1s or 2s or 3s or 4?
4.
4.
अरे भाई थोड़ा सोचो यार. You guys are.
No, 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 no. 4. Like 1 0.
What is 1s or 2s or 3? We got 0, right?
Yes.
0. Yeah,
0s or 4 is this.
yeah.
That is 4 only now.
1. That's 4.
A.
X is or 0 is X, right?
Ah, tell. We are saying something.
X or 0 is X, right? Then 4 or 0 is also 4.
I said 1s or 2s or 3s or 4, right?
Yes.
Now 1s or 2s or 3 is 0.
Yeah.
So you should do 0s or 4, correct?
Yeah.
So 0s or 4 is 0 is nothing but 0 0 0, right? In binary.
Yeah.
4 is nothing but 1 0 0, right? If I do a XOR, 0 0 is 1, 0 0 is 1, 1 0 is, sorry, XOR, right?
Yeah,
1.
Right? So it's
Yes.
yeah.
nothing but,
It's
4.
4 only, right, bro?
yeah, 4. Oh, did you guys mention 4?
Yes.
Yes.
Yeah,
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 yeah.
yeah.
Sorry, sorry. Yeah, my bad. Okay. 5,
1.
right?
Yeah.
6,
So will it follow any pattern?
exactly. So I want to show you that, but we'll write till 8 or 9, okay?
Okay, okay.
Yeah.
It's again. S- Yeah, 7. 8. Okay, okay. 0. Got it.
8.
Nice. This one?
1.
Good.
2.
Will it be this?
11. Yeah.
Yeah. Okay.
Not 2.
How many guys have seen the pattern?
It's like there. Yeah, for the even numbers, it was being like, yeah,
Not even odd, but
the
there is
next
a
one.
very good pattern. Okay. The pattern is
Yeah.
do modulo with 4. Okay. So what is the
Hmm.
modulo with 4?
1.
1 modulo 4 is.
1.
1.
So in this case, okay, we will take some cases. Okay. Reminder, which is n modulo 4. Okay. If reminder is 0, if, sorry, yeah, our reminder is 1, right? First, reminder 1, reminder 2, reminder 3, reminder 0. Okay. This is nothing but reminder 1. So when this is 1, this is also 1, right? 5
Yeah.
modulo 4 is 1, correct?
Yes, yes.
Yeah.
1.
So
Yeah.
9 modulo 4 is also 1.
1.
So can you see for all of them, the answer is
1.
1.
1, right?
Yeah.
Yes.
So if we do a reminder with modulo, if you do a reminder with 4, and if the value is turning out to be 1, the answer will be always 1.
Okay.
Hmm.
Next, let's talk about reminder 0, which is nothing but 4, 8.
Hmm.
So can you
12.
see it is nothing but for 4 it is 4, for 8 it is 8, for 12 it will be
12.
12.
So can I write it as n only?
N.
I
Yes.
mean,
Yeah.
yeah, n only.
Yes.
Mm.
Yeah. Next, reminded 2,
The 3.
Six question. N plus one.
right?
Next element. Hmm.
Next element, n plus 1.
Yeah.
Zero.
Zero.
Sampath, wait.
हाँ जी, समझ आ गया समझ में? So do
Yes,
you
bro.
see this pattern?
Mm.
So the pattern is you do a mod with 4, okay, and based on the cases you get the number, okay. So if we talk, okay, is the pattern clear for 4 of you?
Yeah.
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 What, Manan? Isn't it
Yeah,
clear?
yeah.
Is
Yeah, it is clear.
yeah,
Pattern is changing after 4 elements. That's the reason for mod by 4.
yes, correct. The pattern is changing after every 4 elements. That's why it is mod with 4.
Okay.
Okay. Now, given the question was L comma R, right?
Mm.
If I
Yes.
say 1 to R, then it's done, right? I will just if you just plug in this formula, you get the answer, correct?
Hmm.
Arey bhai,
Yes, bro.
whatever the
I mean, is it fixed for the thing is it fixed for every interval like the 4?
every interval it is repeating. We saw it. If I write further also,
Yeah.
you will see this pattern again repeating. Okay.
Okay.
So this see what when I talked about 6, what do you mean by 6 from 1 to 6, right?
Yes. Yes.
So if I
Yeah.
say you 1 to R, can you guys do it in big O of 1,
Yes. R modulo 4.
right?
Yeah.
R modulo 4, and then you are done with the value, correct?
Yeah.
Clear, Sam Manan?
For that also we need to run for loop, right? Yeah. Like I did not get constant one.
What I am saying you is give. I am not saying L to R. I am saying 1 to R. Okay. When I
Okay.
talked about 7, what do you mean by 7, Sam? It is nothing but 1s or
One.
2s or 3s or 4s or 5s or 6 or 7, right?
Yeah.
So
Yeah.
we just saw the formula. If R is 7, 7 modulo 4 is 3.
3.
3.
The answer will always be 0 only, right? So why you need
Yeah.
a for loop? You don't need a for loop, correct? You just take the
Like
remainder with 4.
you,
Okay, it's just like the if statement, right?
Yeah, it's a if statement. That's all.
like we want only that seventh element or one. We
Bhai,
need to sum
No.
up, right?
bhai.
See, if
Wait,
we
wait,
take
Deva, Deva,
from
Deva,
that
Deva,
particular range also.
Deva,
Hmm.
1 second. I asked the question is XOR from 1 to n. Okay.
Yeah.
The initial question was L to R. But now I am changing that question to 1 to R.
Okay.
Not L to R. 1 to R means if I tell you 7, it is nothing but 1 XOR, 2 XOR, 3 XOR, 4 XOR up to so on up to XOR 7.
Yeah.
So did we get this in constant time by seeing this pattern?
Okay. Okay.
Yes.
Okay. Okay. Got it, bro. Sorry.
Yeah. Sorry to
Yeah. Okay.
interrupt Deva, but yeah, I just want to make sure.
Yeah, got it, bro.
Okay. Is Manan clear on this?
Yeah, this is clear.
This is clear, right? Now,
Mm.
so you guys got to know from 1 to R,
Yeah.
correct? The question
Yeah.
they asked
Yeah.
is L to R.
L to R.
Okay. So can I write 1 to R as 1 XOR, 2 XOR, up to so on, up to R? Can I write this?
Yeah.
I can write this, right?
Hmm.
Yes.
XOR with 1 XOR, 2 XOR, up to so on, XOR with L minus 1. The
Yes.
reason
Yes.
was
Yes.
given you have to find from L to R. I have decomposed L to R in a prefix sum format. Right from 1 to R, XOR with 1 to L minus 1. What we have seen the property of XOR. A XOR A is 0, right?
Yeah.
That means
Yeah.
1 1 gone, 2 2 gone, up to L minus 1 gone, right?
Yeah. Yeah.
So it will be nothing but L to R only.
Yes, bro.
Yeah.
Now 1 to r you can calculate using this formula.
Yeah.
1 to l minus 1 you can calculate using this formula again.
Yeah. Got it.
If you do XOR, is the answer done?
Yeah.
Yes.
Yes, bro.
Feel आ रहा है? Did you guys
Got it.
Yeah, yes,
Yes.
yes, got it, bro.
Yeah. Yeah. I bro. I feel I.
Chalo, shall we write? Or
Yes,
Yeah.
yes.
Yes.
okay. Okay, so public, I guess it's static. Public static int what get XOR till r. Okay, we will pass a number x.
So
So
you are calculating 1 to R,
1
right?
1 to x. Yeah, correct.
Yeah, got it.
Okay, int reminder is x modulo 4. Okay, the next thing is if else, right?
Yeah.
Okay, so instead of if else, I am writing
Switch.
Switch.
switch. Anji, बोलिए. If case is 0,
And
And
yes.
if case is one, it is one. If the case is two, n plus one. Case is three, zero.
break is not required, I guess, right?
Yeah, anyhow, we are returning, right?
Okay, case is 1. How much?
Written one.
1.
Manan, case 2.
N plus 1.
Deva.
Case three, zero.
Okay.
Mm.
uh, it will never happen, right? This will never go
Yeah.
because
Yes.
every time it will follow this. In fact, you can remove this also. Cool. Now,
Mm.
so I'm just commenting out this. Hey man, why we got error? It
We
is
are not calling that function, right?
this is out of the class variables. This is the main, so I have to write it here. Okay. Yeah. So we have
Mm.
our method ready with us, right? So
Mm.
the ask was find XOR from L to R. So I will take two numbers, right? Int till R get XOR. Can I do this from 1 to R?
Y- Yeah.
Int till
Till L minus one.
can I
L
do
minus.
this?
Yeah.
What will be
Then
my final?
perform. Written of till R is R till L minus one.
No, should we add any condition like if
Yeah. You have to add. I am not adding SAS, but yeah, you can add it in the in case if it is going minus 0. Okay, less than 0.
says if L equals to 0?
Yeah. That time it is not required. Okay, I mean you can handle this. I'm showing a generic form.
Okay, okay.
Yeah. Okay, so let's run this and let's take some example probably. Okay, from yeah, tell some number. Let's take a small number first so that we can correlate. Maybe 5 to 9.
Yeah.
Yes.
Nice. Want to see in if I should I have to write or do you guys trust on program?
We'll see
Yeah,
once
got
I'm
it,
on
bro.
vacation.
Okay.
Got it.
Okay. Okay, fine. Let me write. Okay. Okay, 5 or 6, right?
Mm.
This is 6. Next we have to
6.
do with 7.
Yeah.
Next I have to do with
8.
8. 0
1.
0 1 1.
9.
9. Next. Yeah. 0 1. Yeah, 1 0 0 1.
done.
Yeah.
Understood?
Hmm.
Yeah.
Cool, right?
Yes.
Yeah.
Okay. Chalo, ठीक है. Okay. Now, from here on, this is what you guys would see. Now we will go to a next level, okay? Where your problem solving comes into picture. Chalo. Now the questions will be a bit tougher. I mean, here we are to learn mathematics, not to do the questions from
Yeah.
private sheet or whatever. I mean, you can do those,
Yeah.
but I'm moving little out of.
Yeah.
Okay. So next thing is, uh, you are given an array. Okay, it's a some array. You have to find the XOR of all subarrays possible. That is 3 XOR, 2 XOR, 5 XOR, 3 XOR 2 XOR, 3 XOR 2 XOR 5 XOR 2 XOR 5. Okay, find XOR of all the subarrays possible. Got it? So are these the only subarrays?
Yeah.
These are the only subarrays, right? So you have to
Yeah.
find this expression. Okay. How many of you can do this in brute force at least?
Yeah. I mean, we have seen the previous case, right? So we'll be like taking the bits and stuff. Then we'll be like performing a XOR operation on each value that we have taken in the particular list. Yeah. So we can.
No, no. The thing is, like, is everyone comfortable writing two for loops and compute this n square approach?
Yeah.
Yep.
That's the first problem we have done, right?
Yeah.
Yeah.
This is the first problem. Where man? I don't
In the code. In the code.
code में तो
He's asking about two for
I
loops.
mean,
bro.
yeah, yeah. I mean, like,
Guys, Deva, you're so confused with subsequence and subarrays. This is
yeah.
subsequence
Sorry,
and
sorry.
subsets.
Sequences.
Subsets.
Yeah.
I am talking about
Sorry. Yeah.
subarrays.
Yeah. Got it.
Okay.
Yeah. Sorry.
Others, can you
Yeah.
guys write two for loops and do this?
Yes.
Yeah.
कर दोगे ना?
Hmm.
Yeah. Yeah.
Sam,
Yeah,
Deva,
yes.
Yeah.
you can do, right? Yeah.
Yeah, 1
Yeah.
to
Yeah.
n, J2.
Okay. Now, if you see this expression, it is nothing but XOR of everything, right?
Yeah.
Okay. Now here comes something as
Contribution.
exactly contribution idea from each number. Okay.
Okay.
Now, in the end, can you guys say 2 will repeat for some number of times in the final array?
Hmm.
In the end, in the final expression, 2 will repeat for some number of times. Can I say that?
Yeah.
Yes.
Can I say 5 will repeat for some number of times? Can I also say that 3
Yeah.
will repeat for some number of times? Correct?
Yeah.
Yes.
Yeah.
If 2 is repeating even
Yeah.
times, what does that mean?
0.
Exactly. The contribution of 2 is 0, correct? Because if it is repeating even number of times, that means all of them will go off.
Yeah.
If
Yes.
5 is occurring odd number of times, then
5.
5.
so any number, if we can find out how many times it is occurring, and if I do the XOR, whether it is 0 or that number, will my answer is done? Can I be able to find my answer?
Yeah.
Yes.
Done, right?
Yeah.
Yeah.
Yes, bro, yes.
You got the intuition what we talked about? The
Yes.
Yeah.
contribution.
Yeah, if it's even number, which means like A's or A is equals to 0.
Yes, yes,
And for the odd time, A's or 0 equal to A, right?
yes.
For odd.
So now the in this array, let's talk about 2. How many times 2 has appeared?
4.
3,
That
4
means the
times.
contribution of 2 is
4.
0.
0.
0.
how many times 3 has appeared?
3.
3.
3 times.
3.
3.
Can I write 3?
Yeah.
Yes.
How many times 5 has appeared?
3.
5.
2, 3.
Then
3.
3, right?
yes,
Yes.
What
Yeah.
did I write?
5.
5.
5.
So if I do 3s or 5, is my answer done?
Yes.
Yes.
Yeah.
3 is there, 2 is there, 5 is there.
At the top 2 is there. Yeah.
2 and 2 are done, right? So
Yes.
we
Yeah.
have left out with 5 and 3, correct?
Yeah.
So 3s or 5 is how much? 101, 011. 1 1 is 0, 1 1. So can I say the answer is 6?
Yeah.
In fact, if you do this computation, you will turn the answer is will turn out to be 6. Okay,
Got it.
then got it. Now the next
Yeah.
question
Yeah.
is
How
how
to
many
find the
times?
contribution?
How many times? How will you identify what? How many
2
times
is being
2
like
has been appeared?
repeated.
How many times 5? How many times 3? I have
Hmm.
explained this concept in MinStack, not in MinStack. Sorry, in minimum of all subarrays possible.
Yeah.
I I want someone to tell me the contribution. If I am at standing at ith position, if the length of the array is n, okay, what will be number of subarrays? I mean, number of times it has been appearing.
N minus I plus 1. Something I remember, but not sure.
Okay, no.
Like the all the left side part
Yes. So
from
one
that
means
number.
all left, all right. Correct.
Hmm.
Okay. Think of. Sahas Manan, can you think of? I have taught you something in the class. If 3 was here, 5, 4, 6, 5, 2 and 1 is if for this is the smallest, this is the smallest. We have taken this count into this count. Remember something like that?
Yeah, yeah.
अरे पेन पेपर लो भाई, पेन पेपर लेके try to write something. You will get 3, 2, 5. We are at standing at 1. How many times 2 will appear? Is this formula valid? Put the values. N is 3, 3 minus 1 into 1 plus 1, which is nothing but 4. 2 into 2 is 4. So can I say 2 has been appeared 4 times?
Yes,
Yes.
bro.
Yeah.
This formula is working, right?
Yes.
So
Yeah.
remember this, the contribution of each element in all the subarrays is nothing but this formula. Okay? You have to remember this. And I can ask you any day,
Minus.
you have to make sure that you just come up with this, okay? I mean, as soon as I ask, you have to say this, okay? N minus I into I plus
Yeah.
1. Okay? Now how this
Minus
is coming?
I. Okay. Hmm.
And how this is coming, it's because of the same fact that we did. This is the distance, this is the distance, and we did. Since here we don't have any bounds, that's the reason. This is I position, right? N minus I means this much. I plus 1 means this much, right? This is N minus I. This is I plus 1. So if I do multiplication, that means each one of them will become the pair. I mean, pair means from the range. Okay. So there are four. So now what I will do is I will go from each element and I will find it out how many times it is appearing. Okay. So
Yeah.
if I for 3, it will be nothing but 3 minus
Three.
0 into
Into
1.
0
One.
plus 1. Yeah,
Three.
3 times.
3 times. So 3 is odd, right? That means
Yes.
it will
Yeah,
have one appearance. I mean, one occurrence. 3 is odd.
Yes.
For 2, we just saw it is 4. 4 means it's an even. Even means all the
even.
numbers
So 0,
cancelled out. 5 means
5. Because it's been like
Five
repeated a
minus.
number of times, 3 times.
minus 2 into 2 plus 1, right?
Yeah,
Yes. Yes.
3. 3 that is odd. Odd means it is appearing one time.
yeah,
Done?
Yeah, got it.
yeah.
Okay. Now, if you see, for each element, we do this one, which is nothing but constant multiplication. And we do the XOR. XOR is also a constant, right? So we are going through each of the element once. So can I say that complexity is,
Big often.
so we reduced from n square to n with just the
And
observation. So in bit manipulation, you guys have to see the pattern or the understanding that how each one of them is contributing or how many times this will make the number as 0. When it comes to XOR, it basically means that you will cancel the same number again and again. So you have to think of that, okay, how many times it has been appearing. Okay. So do you want me to write the code or
Yeah, fine, bro.
uh,
We can get it.
Manan, Sahas,
mm,
done?
Yeah. We can write a method to do that, and
Yeah. Manan, you can write it, right? Or do you want me
Yeah,
to?
I'll do. I'll try.
No, 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 not trying. I mean, this is nothing about trying. This is just
Mm.
constant
Yeah.
multiplication. So you want me to write? I will
Mm.
write it.
No, 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 no. I'll do. I'll do.
Okay, cool. Okay, now what we will do is, okay, let me think of a good question again. Okay, give me a minute.
Bro, I think we need to stop recording. 45 minutes.